Suppose that we have a student group with 5 officers and we need to form a 3-member committee from those 5 officers. How many different ways are there to choose the committee? Well, if we use permutation 5, 3, this would give us the number of committees in order. In other words, if we did this, this would tell us the number of ways there are to lay aside 3 out of those 5 and stick labels on them. For example, first, second, or third. First committee member, second committee member, third committee member. However, we do not want our committees to have an order on them. We want Joe, Mary, Sue to be the same committee as Mary, Sue, Joe, sorry. And so what we're going to do is we're going to divide by the number of ways to rearrange 3 people. Which is 3 factorial. In other words, we're going to take the number of ways to choose the 3 people, which would be 5, 4, 3, first, second, third, and we're going to divide by the number of ways they can be rearranged. Okay, and so this gives me really 5, 4, 3. If we put a 2 factorial and a 2 factorial, we get 5 factorial divided by 2 factorial, 3 factorial, which is 5, 4, 3, 2, 1 divided by 2 times 1, 3 times 2 times 1, 20 divided by 2, which is 10. So 10 is our answer. This particular pattern comes up very, very frequently, and so there's a special name for it. We call this a combination problem rather than a permutation problem. Permutations means reordering, so permute means change the order. So here we do not want to count different orderings separately. We want to count them all as the same possibility. And so what we need to do is we need to take our previously done factorial formula, and then we're going to divide by the number of rearrangements of those R people or objects that have been laid aside. So we're going to divide by R factorial. So what we would have here is, instead of a permutation, we're going to have a combination. So we'll use C instead of P. Combination 5, 3. So we get 5 factorial divided by 2 factorial, 3 factorial. Notice these 2 in the denominator add up to 5 to our n, our number of objects. And we've already figured this. We have 10. Okay, let's practice a few combinations to make sure that we can do it in our calculator. Again, you should duplicate these using the combination function on your calculator as well as the factorials to make sure that you can do it both ways. Here we'll have 6 factorial. What this means is the number of ways that we can take 2 out of those 6 objects and lay them aside, not putting an order on them. So we're going to divide by 2 factorial, 4 factorial. So 6 times 5 times 4 factorial divided by 2 times 1 times 4 factorial, which is 30 over 2, or 15. If we do combination 7, 4, so 7 is the total number of objects. 7 factorial. R is the number that are being laid aside, so that's 4. And then we're going to have 7 minus 4, so 3. If we simplify this using the factorials, we've got 765 times 4 factorial. Down here we've got a 4 factorial and a 3, 2, 1. So doing our cancellation, those go, and we end up with 7 times 6 times 5 divided by 6, which is 35. Combination 10, 9. We would do 10 factorial. Down here we'll have 9 factorial and then 10 minus 9, which is 1 factorial. So notice here we've got 10. If I break that 10 into 10 times 9 factorial, down here I've got 9 factorial. And so now we end up just with 10, which might seem kind of surprising until you think about it. What this is saying is that I have a group of 10 objects. I'm going to lay 9 aside. How many ways are there for me to choose 9 of them to be laid aside in a special group? Well, choosing 9 to lay aside is the same as choosing the one leftover that remains. How many ways are there to choose the one leftover? 10, because I have 10 objects in my group. And so therefore this turns out to be 10. Here's some other notations. Most of these are similar to what you saw with permutations. This one is new. The vertical parentheses, 2 numbers vertically. There's not a fraction bar in between them. And this is a common notation that's often used whenever this comes up in an algebra class, which is not that often. It's kind of an advanced topic. But it does come up and is more accepted than the capital C.